All right, so we're going to talk about the binomial theorem today, which helps us take a binomial, and this is just an example right here, x plus y, and raise it to any power. In this case, we're going to raise it to the fourth power. In the past, you've been taught to do x plus y times x plus y times x plus y times x plus y. And you had to multiply, two of the binomials together, the other two together, and then finally you got two trinomials, you multiply those trinomials together and finally get the final answer. It was complicated. And, if you had to raise something to the 10th power, that would be horrid, wouldn't it? Raise something to the 10th power that way? That'd be a lot of work. Probably take up an entire page, and who wants to do that? This method using the binomial theorem, which uses Pascal's triangle, is so much easier, so much quicker. It's fabulous. One of my favorite lessons. So we've written for you here some basic facts from here to here. Some of these facts I'm going to do in a little different order, mostly because I choose to use Pascal's triangle versus what your book wants you to do first, because I figure we might as well just jump into Pascal's triangle and go from there. So your book wants you to use this lovely little item to find the coefficients, which we'll talk about what that means, and we'll use part of it in certain instances, and we'll use part of it when we do the last example here. But isn't that what we were doing yesterday? Instead of an M here, what did we use yesterday? An R. You'll see me using an R only because I'm used to using an R. So, you might want to change this to an R, an R, an R, and an R. Just because that's what I'm used to using. It doesn't really matter. And so the first fact says the number of terms in your final answer is one more than the power. So look at the power here. What's the power? What's the power? 4. So how many terms is this going to have according to this fun fact? 5. So if the power here were 8, how many terms would you have in your final answer? 9. And so you would write that number of blanks here. And so that's what we're going to, I'm not going to start off with that yet because I'm going to kind of jockey back and forth. And then the fun facts go on to talk about your first and second variable and some of the variables, and then it talks about coefficients. I like to start with the coefficients. So before we do that, write yourself the following note. We're going to get our coefficients from Pascal's triangle. So let's just talk about Pascal's triangle. So I'm going to go to the second page, your page on the back of this. And so those of you watching the video, you might want to scroll forward to the second page because the video is going to go in the order of the pages, not in the order of what I did them in. So on to the second page. All right, so using our knowledge from the Pascal's triangle on the back, we're going to start putting our rows in, or our terms in. So I'm going to start with the fact that we know we have 5 terms, so I'm going to put in 5 blanks. And then anytime you have a plus in the middle of that binomial, every one of your signs in between these blanks are positive because we have all positive values in that binomial. There's no way their products cannot be positive. So we're going to put a plus, 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 plus. Then I always do this one here, this last fun fact first. So we're going to use that Pascal's triangle that we just talked about. We're going to put in those coefficients. So the fourth row of Pascal's triangle is 1, 4. Notice that the second term's coefficient is always the same as the power because that's the same in Pascal's triangle. So 1, 4, 6, 4, 1. If you don't have the same number of coefficients as blanks, you either figured out the blanks incorrectly or you're using the wrong row of Pascal's triangle. So make sure that those line up. So any questions about what we just did with that? You're going to use the fourth row of Pascal's triangle so much that you're going to know it. So when I take a test on something like this with the binomial theorem, I automatically will make Pascal's triangle on my test because I won't give it to you. So you're going to make it and recreate it on your test. You now know how to recreate it if you didn't remember before. And I usually go up to the 5th row of Pascal's triangle. It's possible I might give you something to raise the 6th or the 8th power, and you'll just bring it out as far as you need to. But I always start with the first 5 rows of Pascal's triangle just because. All right, so then we're going to go to this right here. It says the first variable starts with the power of the binomial and decreases by 1 until it equals 0. Well, what does that mean? This is the first term. Notice that it's on the left. We're going to take that first term, whatever it is, and so I'm going to use light purple. And so I'm going to put all of my first terms in light purple. It'd be handy if you color-coded yours as well. You'll see it'll start to get complicated. And because it's on the left, we're going to start on the left with the highest degree. So I'm going to multiply that by x to the 4th. And then I'm going to move to the right in descending order. So I've got times x to the 3rd, times x squared, times x to the 1st. And I normally don't write this, but for demonstration purposes right now I will. That's x to the 0. What is the value of x to the 0? 1. And so normally you won't see me write that because oftentimes you guys forget and you just leave it as x to the 0. Normally I'll put a blank there, I just won't put it there. But that's what it means until it equals 0. Then we're going to look at this term on the right, the y. So I'm going to put my y terms in green. And the y is on the right side, isn't it? Since the y is on the right side, we're going to start on the right side here with our highest power of 4 because that's the power that we're raising it to. And we're going to start with y to the 4th and move in descending order to the left. So we multiply this here by y to the 4th times y to the 3rd times y to the 2nd times y to the 1st. And then normally, again, I don't write this, but for demonstration purposes, I'm going to write y to the 0. And again, that has a value of 1. So then, and then that's what this second one here is saying, but I don't always start from the left because that's what they're saying. It goes in increasing value. It's much easier if your variable or if your term's on the left, start on the left with that highest degree and move in decreasing order to the right. If your term's on the right, start on the right with that highest degree term and move to the left in decreasing order. It's much easier to do it that way. Then, this is something that you might want to pay attention to, that some of the variables equal the power on the binomial. So the power on the binomial is 4. Look at some of our exponents. What's that add up to? 4. What's that add up to? 4, 4, 4, and 4. So that's how you can check it. And we're going to use that little fun fact later on that last example on the back of this page. All right, so then from here we're just going to simplify. So be careful with your simplifying. Obviously, 1, we're not going to write that. X to the 4th is our first term because y to the 0 is 1. And then for the next term, we just have 4 times y cubed times y. So we get a plus x cubed times y. Do not write y to the 1st power. We don't write exponents of 1 or coefficients of 1. And then the next term is easily 6x squared y squared. And then we have plus 4x y cubed. And then finally, just plus a y to the 4th. So that was a lot easier to expand that binomial of x plus y to the 4th. We had 2 steps and it's done. Rather than have to do that x plus y times x plus y times x plus y times x plus y. You just found a shortcut. And in less than a minute, you'll have that problem done. Once you get the hang of it, less than a minute, you're done. Questions on that? All right, so let's talk about the difficulty that the book likes to make things. So they like to use this little thing right in here. So look at this complicated expansion formula that they give you. You'll never ever see me use this. I just find it a little kind of crazy and confusing. But I do find this part important for later on. You notice that they're using an R there now instead of an M. That's why we changed our M's to R's. We will use that later on. It's Grand Central Station through here. But let me just prove to you that this coefficient right here, I could do this to every single one of these coefficients, but this coefficient right here does match this formula which they're using here is n and r. We'll talk about what n and r are in a minute, but let's just suffice it to say that n is your power, and r is whatever your second term, wow. R is whatever your second term is raised to in that term. So if I'm looking at this term right here, y is my second term, because isn't that my second term in the binomial? So y is my second term. What is it raised to? What power? What power is y raised to? 2. So that's your r. So your r on this term is 2. Your n for every term is 4, because your n is always the power of the term. So what's your y on this term? I'm sorry, what's your r on this term? 4. What's your r on this term? 3. R. R here is 2. R here is what? 1. What's your r here? 0, because there is no y term. So whatever the second term's exponent is, that's what r is. So I'm going to take this right here, and we're going to find the coefficient of 6. I'm just going to prove to you that we could have done this for every single one of these 5 terms, and you're glad you didn't, because we used Pascal's triangle. So our n is 4, because that's the power that we're raising that binomial to. We already talked about why the r is 2. This changes for every one. This left part will stay the same, but this part changes for every term, depending upon what the power of that second term is. And so, based upon our formula from yesterday, we're going to take 4 factorial and divide it by 4 minus 2 factorial, and then 2 factorial. We're going to learn an easier shortcut today, but for right now, didn't this give us 4 factorial over 2 factorial, 2 factorial? Which one of these is the biggest number? Trick question. They're the same. So remember yesterday our shortcut was to take 4 factorial only out until we hit a 2 factorial, or whichever one was larger. Since they're the same, we're going to go out to 2 factorial. So we've got 4, 3, and then we're just going to write 2 factorial instead of 2 and 1. And we've got 2 factorial, and I'm going to write the other 2 factorial as 2 times 1. So our factorials of 2 cancel out, and then the 2 in the denominator will cancel with the 4 twice. So we're left with 2 times 3 only, which is 6. And isn't that the coefficient of our third term? This is our coefficient of the third term. So it worked, did it not? Do you want to have to do that for every single coefficient? Wouldn't you rather use Pascal's triangle? Yes.
Did you just pick a random?
I just picked a random term. I could have easily have picked this one to do, and it would have looked identical to this, but instead of the r here being 2 on this one, what is our r? 3. We would have come out with a 4. You can try it. If you don't believe me, try it. It will come out to be 4. My point is, that's a whole lot of work, isn't it? I just saved you a lot of time. We're going to use Pascal's triangle. We will have to use this knowledge later on, and I'll show you that on the last problem. So are there questions on this before we move on and actually raise some additional ones? Question? Oh, you're stretching. Okay. All right, so let's look at these, and I want to talk about these only because it's just some difference in notation that you're going to have, and it's what we just did up here, finding the coefficients, but they've given you the combination notation. And then if you look at, where'd it go? Oh, if you look at this right here, all they've done is change the combination notation from a C combination of n items taken r at a time. They've just changed it to just an n and an r over each other. They took the C out, they made it look like a fraction without the fraction bar. Both of these, this one and this one, are both identical to that formula there that we used yesterday. So it's just a difference in notation that they want you to get used to seeing. And so as we look at these here, I'm going to let you in on a little shortcut. So it's more of a shortcut than the one that we just talked about. So here's the shortcut, and we can use our shortcut on A and B only. I'll tell you why we cannot use it on C and D in a minute. So we're going to use a shortcut here. So instead of doing 8 factorial over 8 minus 2 factorial times 2 factorial in the denominator, here's what your shortcut's going to look like. And mind you, the new notation for this one would look like this, with an 8 over a 2. You could see it as either way. So here's what the new shortcut looks like, and tell me if this doesn't work. Whatever this number is here on the right, whatever r is, instead of writing out 8 factorial all the way out, 8, 7, 6, 5, 4, 3, 2, 1, this is telling you, for your shortcut, write only the first 2 numbers in the 8 factorial. So instead, we're just going to write 8 times 7 over. And then you're going to put the 2 factorial in the denominator, 2 times 1. So the 2 times 1 came from a 2 factorial here, 2 factorial here. And the 8 times 7 right here came from just it came from the first 2 numbers of the 8 factorial, mostly because r is 2. If r were 3, what if this were 3 here? What would you have written here? Bless you. 876. And then in the denominator, you'd have 3, 2, 1. Now, why does this work? Well, let's think about this. In the denominator, if we used the formula that's above here, wouldn't the denominator be 8 minus 2 factorial? What factorial is that? 6 factorial, right? So hang on. If we were to do it the other way, wouldn't it have been 8 factorial over 8 minus 2 factorial 2 factorial? True or false? What does that equal? 6 factorial. So the shortcut yesterday, didn't we just write out 8 factorial and stop at 6 factorial? So we did 8, 7, and we stopped at 6 factorial. And didn't that cancel the 6 factorial in the denominator? I'm just getting rid of the 6 factorial here. And we've got the 8 and the 7 right here. I just didn't write the 6 factorial here, and I didn't write the 6 factorial down here. And here's the 2 factorial from this one. Now, if you don't like this shortcut from here to here, then do it this way. I don't care. I mean, I'm just showing you, for those of you who like it, like Sam, you probably would like this. No, you don't like that at all?
Shortcut.
You like the shortcut, this one. Yeah. So it's for people like you. I'm showing you this. But if you don't like that and you're like, what? Then go back to this. Either the very long way, or this is the first shortcut, this is now your second shortcut. So essentially, we're going to get, either way you do it, this is going to end up being, doesn't the 2 cancel into the 8 4 times? And don't we end up having 4 times 7, which gives you a final answer of 28. So try the new shortcut on B. Try the new shortcut on B. This is notation that is no different than a combination of 10 items taken 3 at a time. So your n is 10, your r is 3. So on the new shortcut, what's going to go in your numerator? How many numbers of 10 factorial? 10, 9, 8. You're only doing 3 because your r is 3. Since this number here is 3, we're only doing 3 factorials of 10. And then the denominator, you have to do 3 factorial, 3, 2, 1. And then start your canceling. The 3 cancels into the 9 3 times. And then the 2 can cancel into either the 10 or the 8. I prefer to cancel the 2 into the 8. It makes math easier when all is said and done, especially if you're not using a calculator. And so we're really multiplying 10 times 3 times 4, which gives you what? 120. All right, well, let's talk about C and D. C and D, you cannot use a shortcut. So, can't use the shortcut when r is equal to 0 or n is equal to r. That's r, shocking but true. Shorten it up. And that's from here to here on these two. So this is important. You can't use a shortcut on C and D because look, the fact that this is 0, and I'll show you why you can't use a shortcut. We can talk about you actually will end up realizing that there is a shortcut to this one too. So anytime r is 0 and anytime n and r are equal, this is what happens. So let's go ahead and use the longer version of the combination formula. So again, your new notation for this would have been 7 over 0 with parentheses. So according to the formula, we would have 7 factorial over 7 minus 0 factorial. 0 factorial. What is the value of 0 factorial? What's the value of 0 factorial? 0. So this simplifies to 7 factorial over 7 factorial, and then this right here becomes 1. Did you say 0? Oh, okay. No, it should be 1. 0 factorial has a value of 1. So really what happens is we end up with 7 factorial over 7 factorial times 1. When you have 7 factorial over 7 factorial, what does that do? They cancel out, and that technically is a 1 in the numerator and a 1 in the denominator. So what is the value altogether? 1. And what we're doing with this combination is finding coefficients. So that's interesting that you got a 1. Let's see what happens with D. So with D, we're going to do the same thing. And again, the old-fashioned notation would be a combination of 9 items taken 9 at a time. So we would have 9 factorial over 9 minus 9 factorial, 9 factorial. Doesn't that give you 9 factorial over 0 factorial, 9 factorial? So we have that 0 factorial again. That 0 factorial simplifies to a 1. The 0 factorial has a value of 1. And then the 9 factorials do what? They cancel out and you get 1 and 1 in the numerator and denominator. So again, your value for this is what? So we could hypothesize that when r is equal to 0, or when n and r are identical, what are the answers going to be? 1. If I change this number here to any number you can think of, is that going to make the value not 1? Aren't you going to get whatever factorial over whatever factorial? So I hypothesize that whenever r is 0, the coefficient is 1. And that's how you get that coefficient of 1 in Pascal's triangle, because think of this. This is the exponent of that second term. Isn't the exponent of the second term always going to be 0 in the first position? And what did the coefficient end up being? 1. And over here, when they're the same, you get a coefficient of 1 as well. So if these are the same, you're going to end up with that 0 factorial down here, and you're going to end up with the same factorials here. So I hypothesized that you could make a shortcut here as well and say, oh, it's 1. Valeria? Yep.
Like if I just see it like that,
Yep.
I just write 1?
Absolutely. I won't force you to show work on that. That's you using your brain. Okay? So all of that was just the long way of finding a coefficient, and we might have to use that later on. So for the rest of class, we're going to actually expand binomials. And I'm changing b over here, by the way. B is no longer going to be this. So we're changing b to read 2 minus x raised to the 5th power. But we'll do that in a minute. let's start with this one. What does that power of 4 tell you? It tells you two things. What's thing 1? 5 terms. So it's always one more term than the power. And then what row of Pascal's triangle are we going to use? Nope, the 4th. It's the same row. Technically it's the 5th row in Pascal's triangle, but that row is called the 4th row because the first row is the nth row. Does that make sense? Or I'm sorry, the 0th row. So we're going to use the 4th row of Pascal's triangle. Remember, the 4th row of Pascal's triangle, the second number starts with 4. So here we go. Start with your number of blanks. So I've got 5 terms. So 1, 2, 3, 4, 5. And just like before, I have a middle sign here of positive. So anytime your middle sign is positive, the sign in between these blanks are always all positive. What are the coefficients of the 4th row of Pascal's triangle? 1, 4, 6, 4, 1. That is such a popular binomial to raise a power to that you're going to get used to that. You're just going to have it memorized because you're going to use it so much. And then we're going to start from the left. My x is on the left, and so start with your power of 4 and start on the left. So times x to the 4th, times x cubed, times x squared, times x to the 1st, and I'm not going to write this time the x to the 0, because I normally don't. Then we're going to start from the right, and on the right side is a 3 this time, and I threw this one in here because I need you to understand what happens to the final coefficients when one of the terms is a number and not a variable. So on the right, because 3 is on the right, we're going to start here with 3 to the 4th power and then move to the left. So times 3 to the 3rd, times 3 to the 2nd, times 3 to the 1st, and again I'm not going to write 3 to the 0. Then stop here for a moment and let's think about fun fact number 1, 2, 3, 4 above. Fun fact number 4 above says that the sum of the variables power are the same. Well, that's kind of written weird, but the sum of the variables powers should equal the power on the binomial. So notice that this is the only variable, its power is 4, that equals the power of the binomial. What did these add up to? 4. And how about these? 4, 4, and then 4. So that's a catch for you, that if they don't add up to 4, you must have done something wrong. And then from here it's just a matter of simplifying. More steps is better than less because you're less likely to make an error. So this one's easy enough. I get x to the 4th, and then 4 times 3 is 12, so I get positive 12x cubed. And then we get a little bit more complicated. So from here I'm going to start to write some things out. So I've got plus 6 times x squared, and then my 3 squared, what's 3 squared? 3 squared? 9. Right? And then plus 4 times my x cubed, I'm sorry, x to the 1st, so I'm not going to write to the 1st. And then what is 3 to the 3rd?
27.
That's 27. And then finally, I can actually write out what 3 to the 4th is. What's 3 to the 4th? 81. So that one was simple. And then from here, you're just going to simplify these two middle terms, 6 times 9 and 4 times 27. So we get a final answer. Six times 9 is 54, x squared, and what's 4 times 27? 108x plus 81. So that's our final polynomial. A lot easier than doing x plus 3 times x plus 3 times x plus 3 times x plus 3. And you can get pretty quick at that, so that should take you less than a minute to complete. Yes?
Can we just skip to that last step instead of like...
Well, the problem is that you could, but a lot of you do the multiplication wrong. And I see a lot of errors going from here to here because you're just we either miss something or too much of a hurry, or we make like 3 to the third power 9 instead of 27, just stuff like that. So just take your time and do it in pieces, I would just suggest. And then, especially when we do the last one that we're going to do today, it gets fairly complicated. This one is complicated for a couple of reasons. Can you tell me why? What are some issues that you see going on here? The x comes second, and there is a negative, right? So that's going to affect something. And then this is going to tell you something. What does this tell you? How many terms do I have?
6.
So 6 terms. What row of Pascal's triangle? The exact same row. So the 5th row, which is the row where 5 is the second number, right? So the 5th row of Pascal's triangle. All right, so before we can do that, though, we have to address the fact that we have this negative right here. So write yourself the following note. When there is a negative, alternate signs starting with a negative. Now the first term is always positive. So what I mean by alternate signs starting with a negative is in between the first 2 blanks. So because we have 6 terms, we're going to write here 6 blanks. And we're going to start here in between the first 2 blanks with a negative. And then we go positive, negative, positive, negative. Why? Because it works that way. Then what do? What do I start with first? My coefficients. So look at the back of your page. You'll start to learn this row as well because 5th power is used often. What does the 5th row of Pascal's triangle look like? Starts with 1. The second one is 5. I know that for sure. What else? 10, 10, 5, and 1. So again, the numbers from that row of Pascal's triangle should match the number of blanks. So if you're having trouble finding the correct row, if you know the number of terms, it's easy to find the row that matches those terms, right? And then from here, you're going to start on the left. So on the left, I have a 2. So I'm going to start with my 2 on the left and raise it to the 5th power. Then times 2 to the 4th, times 2 to the 3rd, times 2 to the 2nd, times 2 to the 1st, and I'm not writing 2 to the 0. Then starting from the right, because my x is on the right this time, I'm going to start my x on the right side, x to the 5th, then move to the left, x to the 4th, x to the 3rd, x squared, and x to the 1st. Stop and look at your exponents. What do they add up to? Do they all add up to 5? Yes. So you probably did good there. Then slowly start to simplify. Don't be in a big hurry. What is 2 to the 5th? It is 32. And then it's easy. Well, I'm gonna go ahead and go pieces from here. So minus 5 times. What's 2 to the 4th? 16. So 5 times 16 times x. And then plus 10. 2 to the 3rd is 8. And then x squared. And then minus 10 times 2 to the 2nd is 4 times x cubed. Plus This one's easy enough to do. 5 times 2 is 10. X to the 4th, and then minus x to the 5th. And then from here, just finish it up. 32. What's 5 times 16? So we've got 80x. 10 times 8, 80x squared, that's positive. And then 10 times 4 minus 40x cubed plus 10x to the 4th minus x to the 5th. And so this is your final polynomial. Your highest degree term in that polynomial had better match the power of your binomial. And so the power of the binomial is 5. Highest degree term is over here, and that has a power of 5.
You not have to put it back in order? Like
Nope.
okay.
Nope, not unless for some reason the directions said so. And if they did say to put it in descending order, then you need to take the sign with it. But I will never ask you to do that. Any questions on this before we do one more problem? I don't know why we're packing up. I've got lots of time left. Are you leaving? Oh, okay. Shoes packing up. Making me nervous when you all shuffle your papers. Okay, so let's go to your second. So here's Pascal's triangle. It is fascinating. You can have an entire class on Pascal's triangle. That's how much information is in this little triangle. How many of you remember Pascal's triangle? Do you remember how it's formed? Where are these numbers coming from? Obviously the first and last numbers are always ones, but where do these numbers in the middle come from? Adding what? Well, like how do we find 10? The two numbers above it add to give you that 10, right? And so how did we find 3? What are the two numbers above it? 2 and 1 add to give you the 3. So what are these two numbers going to add to give you? Down here. 15. So let's find this row right here. So this row, it starts with 1, doesn't it? And then 1 plus 5 is what? So there's a 6 in between the 1 and the 5. And then 5 plus 10 is what? So there's a 15 in between the 5 and the 10. And then we have 10 plus 10, which is 20. And we have 10 plus 5, which is 15. You'll see that Pascal's triangle is always symmetrical. Bless you. And then we finish off with 6 and 1. You could split Pascal's triangle right down the middle here, and you'll see that the left half is identical to the right half. If there is an odd number of terms in the row, which this row has an odd number of terms, the middle number is the only number that's different from all the others. You can see that the 20 is the middle number, and the left, numbers to the left, and the numbers to the right of 20 are identical. So it's always symmetrical. And so if you look at the front page of these notes, it says that the coefficients on the terms increase and then decrease in symmetrical order. That's that last fun fact that's on the front. That's what it's saying. They increase and then decrease in symmetrical order. That's what that means. It's referring to Pascal's triangle. So I want you to find the 7th row of Pascal's triangle. You find the 7th row of Pascal's triangle. Share with a friend what you got. How many terms are in the 7th row of Pascal's triangle? 8. 1 more than the power. Isn't that the same thing as the number of terms when we raise a binomial to that power? So obviously we're going to start with 1. What's the next one? 7, and then 21, then 35, then 35, and the symmetry starts, right? Okay. How do you know which row is the nth row of Pascal's triangle? Well, look at the power here. This is the 0th row of Pascal's triangle, and it contains the number 1. I like to let you know that in Pascal's triangle, it's really based upon a base of 2, and we're showing here a base of x plus y. But if I wrote a base of 2 with that same power, this is another fascinating fact about Pascal's triangle. 2 to the 0 has what value? And what does this row add up to? 1. 2 to the 0 is 1. The value of all the items in the row added up to is 1. So then the next row is the first row of Pascal's triangle, so that would be 2 to the first. What do these numbers add up to? 2. What's the value of 2 to the first? 2. Fascinating. And then this would be 2 to the seconds. There are 3 terms in the 2 to the second row, and what do they add up to? 4, and what's 2 to the second? 4. And then we could keep going. We'll do one more. 2 to the third. 2 to the third, it has 4 items in that row. What do all 4 of those add up to? 8. And what's 2 to the third? 8. So that means that the 32nd row of Pascal's triangle would have a value. How many terms would the 32nd row of Pascal's triangle have? 33. All 33 of those numbers would add up to whatever 2 to the 32nd was. And so I can tell you quite easily what each of those rows add up to. The other thing that would be important for you is to realize that this, whoops, let me get the right diagonal. This diagonal right here tells you what row it is. So if you're wondering, okay, well, I have to find the 8th row of Pascal's triangle. Or let's find this, in this case, the 6th row, since we don't have it out to the 8th row. The 6th row of Pascal's triangle, just look in Pascal's triangle, which second number is 6. That means, oh, this is the second number that's 6. This is the 6th row of Pascal's triangle, so I'm going to use that one. This is the 0th row of Pascal's triangle, because what number is really right here? 0. That's the second number in that row, even though it only has 2 numbers in the row. The second number is 0. So that's 0, 1, 2, 3, and so forth. You will always see a pattern with these numbers going in the diagonals. That's a story for another day. On the reverse side, so we're going to stop here with Pascal's triangle for right now. And then on the reverse side, we're going to go back, and we're going to raise x plus y to the 4th power. So we need to use this row right here of Pascal's triangle. So you might want to highlight that in yellow or whatever. So how many numbers is that? 5. And remember how many terms we said we had in our binomial that we're raising the 4th power? How many terms are going to be in this binomial here? 5 terms. Look at how many terms there are here. This becomes our coefficients based upon those fun facts. So we're going to revert back to the first page. All right, so one thing that I would like you to do before we do example 3, I want you to find the 8th row of Pascal's triangle. Since we've been away for a little while, I want to see if you can write that 8th row down. What's the first number? 1, then comes 8, then 28, then 56, then 70, then, and then it starts in reverse, right? The symmetrical pattern. All right, so you are going to complete example 3 on your own. I do caution you a couple of things. By this time, you should know how many terms we have. How many terms do we have? 5 terms. We're going to do 1, 2, 3, 4, 5. Then be really, really careful. I'm going to let you do your coefficients in a minute, but be careful when you take this 2x here, bless you, and raise it to its power. This because this is a more complicated term than we've worked with. If I raise the 2x to the fourth, I would not put it on my blank like that. I would put it on my blank as 2 to the fourth, x to the fourth. 2 to the third, x to the third. 2 to the second, x to the second. Because what's going to happen is you're going to write this 2x to the fourth as 2x to the fourth. You're going to forget to take the 2 to the fourth power, and it's going to mess up all of your coefficients. So make sure you put that on the blank when you're going from left to right. So you go ahead and finish it. And then while you're doing that, I'm going to quietly do it up here. Don't forget that you have a negative. Mm-hmm.
Or do you
2 to the fourth, x to the fourth goes in the first blank.
It's like because there's something in the edge.
Because the 2x is on the left. So you start on the left, which is the first blank, and you have to raise that. You start with the highest degree, which is 4. So you raise that to the fourth, x to the fourth, and then you go to the right in descending order.
Okay, so it's 2 to the 4th, x to the 4th.
Yep, that goes in that first blank. You have to figure out your coefficients based upon Pascal's triangle, though, right? Okay. Now, if you try to add up your exponents, it won't work this time because we took the 2 to the fourth and the x to the fourth instead of just leaving it alone. So do keep that in mind. When you get done, you can share your answer with those around you. See if they agree with you. Okay, so that's what it should look like. If you've messed it up, I've color-coded it for you, so you got to be able to figure out what your errors are. But don't forget that, your coefficients from Pascal's triangle were 1, 4, 6, 4, 1. They come first. Have a good lunch. We'll finish this tomorrow. All right, so we're going to actually find these particular terms in this particular binomial that's been raised to the 12th power. We are going to use, bless you, if you look at the back, or I'm sorry, the front of your sheet, remember, I'm not going to flip on this one, but if you look at the front of your sheet, right here, remember this part that I said was gobbledygook at the very first and that was confusing, but that we would use it for the last problem? So here it is. I want you to write yourself a note here. We are going to use a combination of n items taken r at a time times x to the, and this is where I'm going to kind of detour a little bit. I mean, don't worry so much about the exponents. I'll show you how to figure them out without having to do them mathematically. So x to the n minus r, that's a minus, and then times y to the r. It's important to realize that x and y are not necessarily x and y. I realize that x here is our first term. But your first term here, couldn't it be a 2x? Couldn't it be just the number 5? So this is referring to the first term. The first term is not necessarily x. It could have a number or a different variable associated with it. So what this is saying is, whatever this term is, you have to raise it to that power. And then y to the r power refers to the second term. And in this case, our y is 3. So our second term, 3, we're going to have to raise to some power. What do you know about these two powers here? What do they add up to? The power of the binomial. So the important thing to realize is that those two powers have to add up to, in our case, 12. So let's start here with x to the third. We're going to find the coefficient that's in front of the x to the third. So I'm going to put in a, and I just chose the letter a just because I did. You can choose whatever variable you want to. But we're going to find the coefficient that's in front of the x cubed term. Now you could take x plus 3 to the 12th and you can expand it all the way out. How many terms would it have? 13. You can find all those terms and then focus on the x cubed term. I mean, you could do that, but that's a pain. What I'm going to show you is much quicker. And furthermore, what if I had put this to the 32nd? Now how many terms would you have? 33, and who wants to expand that? So this is a quicker way. So to find a, we're going to take a combination of this value right here is my n. Always my n. So in this case, we're going to take a combination of 12 items. So for every single one of these, it's going to be 12 because that's the power of the binomial. And then the number that goes here is r. Well, r is the exponent of our second term. We have to find out what that is. I know the exponent of my first term is 3. So we're going to put that in here. We're going to hold off on the other part for a minute. So I've got x cubed. That was given to me. But then I have to multiply by my second term here is a 3. So I'm going to take that 3 and I'm going to raise it to some exponent. So I have to figure out what this exponent is. What do the two exponents have to add up to? 12. So 3 plus what is 12? 9. So I know that this exponent is 9. Why? So write yourself a note. These right here must add to 12 because that's the power of my binomial. If my binomial had a power of 15, what would this have been? Still that being 3, what would this have been? 12, right? So you just take, and if you want to for your note purposes, you can put up here 12 minus 3. That's how we got the 9. So when I do this one, I'm going to do 12 minus 7, so I'll have 5. 12 minus 9, I'll have 3. All right, so since that's 9, I also want to put a 9 here, because those are the same. From here on out, it's just doing math. So we're going to actually find the combination. And the shorthand here isn't really very short. The shorthand is saying, since that's a 9, it's saying take the first 9 numbers of the 12 factorial and then put it over 9 factorial. So that's a lot of numbers, but we're going to go ahead and do it. So I've got 12, 11, 10, 9, 8, 7, 6, 5, and 4. All over 9 factorial. 9, 8, 7, 6, 5, 4, 3, 2, and 1. And then don't forget we still have times x cubed times 3 to the 9th. Any questions as to what I did there? So now we're just going to start canceling. So I have a 9, 8, 7, 6, 5, 4 here. So I can cancel all of those there. That leaves me canceling couldn't I cancel the 3 and the 2 together with what? 3 times 2 is 6. 6 goes into what number above? 12. So I could cancel that into the 12 2 times. And so that leaves me with a 2, an 11, and a 10. Could I have canceled differently? Sure. So long as your 2 times 11 times 10 comes out to be 220, or whatever you're multiplying comes out to be 220. And so my answer is going to end up being 2 times 11 times 10 times x cubed times, what's 3 to the 9th? Calculator, 3 to the 9th. A large number. 19,683. So now we have to multiply these together and then multiply them to the 19,683. And we get, finally, 4,330,260 x cubed. But that technically isn't the answer, because what are they really asking for? The coefficient. So you have to be really careful on Math Excel to see how they want the answer written. If they are asking just for the coefficient and you put the x cubed in there, they're going to mark you wrong, because the x cubed is not the coefficient.
I totally missed how you got the 2 instead of 12.
I took the 3 and the 2 together. I knew they both went into 12. 3 and the 2 together is 6, right? 6 goes into 12 twice. Right, and then so that's how that left me with those, because I didn't have anything else to cancel out. Megan?
Why did you just stop at 4?
Because remember the shortcut from yesterday, you look at this and it says that number on the right, the shortcut is to only write down that many numbers from that factorial. So this was 9, the first 9 numbers in the factorial of 12. And then you always write it over that factorial, 9 factorial. You can do it the long way. You could do the n factorial over n minus r factorial times r factorial if you want to. It's longer. So we're just choosing to shorten it up. Any other questions before we go on to the second one? We good? Okay. So then let's look at the second one. Let me figure out what color I'm going to use. Let's use purple. Okay, so for the second one, I'm going to put a in front of the x to the 7th. So I'm just going to use the same process. A is equal to a combination of how many items? How many items total? What's my power of the binomial? Power of the binomial is 12. So combination of 12 items. I have to wait on what r is for a minute. And so then I've got times x to the 7th. And then my second term is 3. So I'm going to do 3 to the what? 7 plus what is 12? To the 5th. So this becomes 3 to the 5th. So then this is a combination of 12 items taken 5 at a time.
Wait, that's minus 3 to the 5th?
That's a times. This is a times. They're all multiplication. It's multiplying. All right, so now we're ready to do the math. So we have, I'm going to write down the 5 here. It says to write down the first 5 numbers in the 12 factorial. So I'm going to write down 12, 11, 10, 9, and 8. And that's all divided by 5 factorial. So 5, 4, 3, 2, 1 times, don't forget the x to the 7th, and then times 3 to the 5th. So let's start canceling. I'm going to cancel the 5 with the 10. It's my only choice, really. And I'm going to cancel the 4 and the 3. Can't I cancel the 4 and the 3 with what? The 12. So that's what I'm going to do. And then that leaves me with a 2. So I'm going to cancel that 2 right here with the 8 4 times. So I'm left with an 11, a 2, a 9, and a 4. Could you have canceled differently? Of course. And so that leaves me with 11 times 2 times 9 times 4 times x to the 7th. And then what is 3 to the 5th? Why am I the only one calculating it? What's 3 to the 5th? It's not very big. It's a littler number compared. It's 243, right? And so now we have to multiply the 243 to whatever numbers you have here. And you should end up with a final answer that is fairly large. 192,456 x to the 7th. But a really equals what? Huh? No, a really equals this. Did you get something different? Okay. So then I want you to do C on your own. And I will quietly do it here without you being able to see it. And then when you're done, I want you to share with a friend, what did they get? So share your results with those around you. All right, so what'd you get? 5,940. Are we in agreement?